For example number 2, we will be writing the following as entire radicals. So let us consider 5 times the root, or 5 times the third root of 6. Now, I know that what I would like to do, now I'm going to be using the multiplication law, and normally the multiplication law for radicals says the nth root of a times b is equal to the nth root of a times the nth root of b. But instead, what I'm going to do is I'm going to say the nth root of a times the nth root of b is equal to, sorry, that's terrible what I've just written, times the nth root of b is equal to the nth root of a times b. Now, to use the language of radicals, what we're going to do is we're going to make the indexes the same. And when the indexes are the same of two radicals, of the product of two radicals, then it's just simply the nth root of the product of the radicands. So let's get moving. Now, when I take a look at 5, did you know 5? Now, take a look what I'm doing here. I'm considering a. I have this number 5. And really, what I would like to do, this is what I'm thinking, I would like it to write it as the cube root of is 5. So really, and what I have to do that is 5 to the power 3 is 125. So this naturally implies that the cube root of 125, the cube root of 125 is equal to 5. So in other words, instead of writing 5 times the cube root of 6, well, 5 can be written as the cube root of 125 times the cube root of 6. Now, the cube root of 125 times 6 is the cube root of 750. Oh, my apologies. I skipped a step there. Is equal to the cube root of 125 times 6, all under one radical sign. So that is the cube root. 125 times 6 is 750. So in essence, what is the, oh, am I going to say it? Yeah, what is the trick? The trick is to simply write 5 as an expression that matches the index of your root. So now here, when I take a look at 4, now the thought process is actually the inverse of the fourth root, and the inverse of the fourth root is actually 2 to the power of 4. Now 2 to the power of 4 is 16. So this implies that the fourth root of 16 is equal to 2. So when I see this, I have 2 times the fourth root of 4. So now 2 is just simply the fourth root of 16 times the root of 4. The fourth root of 16 times the fourth root of 4. And since the indexes are the same, I'm able to put them under one radical. So I can write this as the fourth root of 16 times 4. And this is the fourth root of 64. 16 times 4 is 64. And if you're having troubles with that, what we do is we just simply write it down like this. 16 times 4. 4 times 6 is 24. Carry the 2. 4 times 1 is 4. Plus 2, 6. There. I hope this helps. Now, let us go into something a little bit more vigorous, shall we? This. Now, F. Now, if you can do F, and if you understand F, you can understand every radical. So really, what do I know? I'm going to write this as f. Negative 2 times, that's how I have to think of it, right? And what I would really love to do is to write negative 2 as change this up so that it's a root, the 7th root. And really what I have to do is I have to think the inverse. So negative 2 to the power of 7, well, negative 2 times itself 7 times is going to be a negative. Now 2 times 2 times 2 times 2 times 2 times 2, so that's 1, 2, 3, 4, 5, 6, 7. So I know that this is 4, 4, and 2 times 2 times 2 is 8. So this is just simply multiplying, so this is 32 times 4, and I believe this is going to be 128. So 2 times itself 7 times is 128. But negative 2 times itself 7 times is negative 128. So far, now this implies that negative 2 is equal to negative 128, the 7th root of negative 128. So instead of writing negative 2, I write negative 128 all to the power, or all to the 7th root, times 6 to the power 7. Now, this is a big monster of a number, but don't be afraid, because I'm just going to simply, since the indexes are the same of the root, 7, I'm going to bring them all under the same radical. So negative 128 times 6, and that is the 7th root. And so my final answer will be the 7th root of this product. So 128 times 6. Now, so let's carry the 1, and that is negative 768. All right. If you have any questions,